This is question 4 on homework 5.2, and it is asking to find the Riemann sum on n intervals and the integral from a to b of f of x dx, which is also the limit as n approaches infinity of the sum f of xi and then times delta x. Can you tell me what was the interval for the function?
It was 0 to 4.
Okay, so the interval is from 0 to 4, which means that our delta x would be 4 minus 0 over n. So those are the two endpoints of the interval. And then we just divide it by n. And x sub I then would be just delta x times I. And also the function for this question was x squared over 4 plus 6. So this was f of x. So the first thing, I'll work on both things together, but once we reach the Riemann sum, I'll just circle it and tell you this is the Riemann sum. That's the thing that goes on to the first question, and then I'll keep just working down. So the first thing that you need to do is rewrite the limit. So this is equal to, so from here, this is equal to the limit as n approaches infinity. And then, I don't know why I keep writing 8 instead of infinity. And then we are plugging xi, which is this, into the function. So we have still the sum from 1 to n. And then we plug in 4 over n times I for x, which is this, divided by 4 plus 6. So this is the function. And then times, and then delta x was 4 over n. So let me just kind of color code it so you can see. So this here is this. This here is delta x. And how we got this, we just plugged in 4 over n times I into the function anywhere we had x. So to solve this, what we can do is I'll just keep writing until we get to simplifying it a little bit. So if we square this, we'll get 16 over n squared times I squared. Then I'll just copy the 4 on the bottom and do the plus 6. And then times 4 over n. Because that sum here only depends on I, we don't have anything with any I in this. This can come all the way up in front of the sum, but not in front of the limit. So this would become the limit as n approaches infinity. Then we can put the 4 over n. And now let's start to simplify the sums a little bit. So 16 and 4 would cancel out and it will become 4 over n squared times I squared. And then we can split that sum into two sums. So we are summing two things basically. If you think about it, if you do 2 plus 5 plus 7, you can just split 2 plus 5 and then add the 7 later to it. We have that property, so I can just rewrite the sum over here and then just put the 6 inside of it by itself. So on the next step, what we can do is this part here doesn't depend on I, so we can put it right in front of that sum. And that would be, again, the limit as n approaches infinity. That 4 over n stays here for now. And here we'll have 4 over n squared. Then the sum of just I squared. And I don't think Dr. Johnson gave you this formula, but this is basically summing 6 in times n. So basically you're doing 6 plus 6 plus 6 plus 6 plus 6, which would be 6n. And here we can just keep doing this, and now we'll substitute the formula for the other sum. So the formula was, when you have the square, the formula is n plus 1, 2n plus 1, And then it is the whole thing divided by 6. And then we have that 6n over here. So let's simplify this a little bit. That n here can cancel with that n square. That 4 can cancel with the 6. So this would become a 2. This would become a 3. And let's just simplify this a little bit more. So here we'll have 2 times n plus 1, 2n plus 1 plus. Into the denominator, we'll have just 3n. And here we'll have plus 6n. And that part over here without the limit is what would go for the Riemann sum. So this here is the Rn part. That's the first question that you guys need to answer. And now let's just find the limit. So what we'll do for the limit is we'll just distribute, take a common denominator and just try to find what the limit is. So that would be 4 over n times. So here we'll have 2 times, and then in the brackets, if we distribute this, n times 2n would be n 2n squared. Then we'll have n and then 2n, which would become 3n plus 1. Over 3n, and then to find common denominator for this, we'll need to multiply and divide that 6n by 3n on the top and the bottom. So I'll just rewrite it like this. So we multiply on the top and we multiply on the bottom. So what do we have here? Four over n. Here we'll have 2 times 2 is 4, and here you have 6 times 3 is 18, and 4 is 22 n square. 2 times 3 is 6. And 2 times 2 is 2. And then that would be all over 3n. And then we can just distribute the 4 over n and then find the limit. Let me just make sure. So this is 4 plus 18 is 22. This is 6. Okay. So now we'll just distribute the 4 over n before we find the limit. So that would become multiplying everything into the numerator by 4, we'll get 88 n square plus 24 n plus 8 over the numerator, the denominator would be 3n square. And now I think using L'Hopital's rule would be the easier. We just need to do it twice. But you can also factor out 1 over, multiply by 1 over n square on the both the top and the bottom. Doesn't matter, maybe. Well, I think L'Hopital is much easier. So we see that we have infinity over infinity. We can use L'Hopital's rule. So that would become the limit as n approaches infinity. The derivative of 88n squared would be 88 times 2n, which is 176, I believe. And the derivative of 24n would be just 24, and then derivative of 8 would be just 0. And here we'll have 6n for the derivative of the denominator. We have again infinity over infinity, so we can do L'Hopital's rule again. And we'll get the limit as n approaches infinity of 176 over 6, which is just a number. We don't have n anymore, so it will be just 176 over 6. And that should be the answer that you put into the second part of the question.